All right. So we should be recording and all good to go. Okay. So, hey guys, as you can see on my computer, we have already decided to move the test to Thursday. So, yay, that way we can have more time tomorrow to review in class. However, you do still have an assignment today. It is graded. It is located. Oh, go away. It is located in Google Classroom, so it is our mixed practice assignment in solving right triangles. Okay, you have the actual worksheets and the answer keys to go along with it. I will be doing a video going over all of it as well, so you guys are absolutely prepared for your test on Thursday. Um, to start with, I'm going to do a quick review on what we did on Friday. So on Friday, we did angles of elevation and depression, and then we did sine, cosine of complementary angle. So you got a packet with all four of these worksheets. So go ahead, pause the video, go get your packet. Okay. So if you guys got your packets of all four of these worksheets, mixed practice solving the triangles is what you guys have to do today. Snap a picture of it and upload it to your classwork. It should be, did I not make it an actual assignment? Okay, I'll go back and I'll fix that and I'll make this an actual assignment. I don't know what just happened. Okay, I will fix that, but that way you could upload it onto Google Classroom. Okay, so you will need Desmos as well, but let's get to it. All right, so we talked about angles of elevation and depression. For a quick review, an angle of elevation is formed by a horizontal line and a line of sight above it. Okay, so when we're looking at this, we have our horizontal line here. Here's our horizontal line, and our line of sight is going to be this blue line right here. So it's like vision where you see your line of sight. So right here, Billy Bob is on the ground. He's looking up at the balloon. So if our line of sight is above our horizontal line, then it is an angle of elevation. Okay. Now, an angle of depression is formed by a horizontal line and a line of sight below it. So our line of sight is still this blue line, but the horizontal line will be now this orange line. So it's whatever's up high, and then the line of sight is below. So if we are in the balloon, we're hanging out, we're floating around, and we look down at Billy Bob, that is a depression angle. So it's going to be referring to this angle right there, while our angle of elevation is referring to that angle right there. Okay. So then for a little quick practice, as we classify each angle of elevation or angle of depression, right here, we have our horizontal line. I want you guys to first identify that, okay? There are two lines that make up an angle. In this case, it's going to be a horizontal line and then your line of sight, okay? The line of sight will be above or below. Elevation, if it is above, right, here's our line of sight, that's above our horizontal line. So that's going to be elevation. Okay. In this case, we have a horizontal line. And then our second line is our line of sight. Okay. It's going to be the angled one. And that is going down. Okay. So this is going to be depression. All right. Now, with this, if we had this triangle right here, okay, this is talking about this angle. So if we have this triangle, right? Here's our right angle. And it wants us to figure out what, I don't know, this side is. We need to figure out how to get this angle. Okay. Pause, think about it for a second. How would we find that blue angle? Okay. So you guys should have recognized that if this is a right angle, then this is also a right angle. So you would take 90 minus whatever our orange angle is. Let's call it 30. 30 equals 60. So this angle would be 60 degrees. Okay, you would find the difference of the two in order to get this angle. And then you could go ahead and use SOHCAHTOA to solve for that extra side. All right, and that's just a quick little, hey, reminder. All right, Number 3 and 4 classify each angle as an angle of elevation or depression. So for angle 3, we're talking about this guy. So we have our horizontal line and then our line of sight. Our line of sight is below our horizontal line. So this would be depression. Okay. In this case, our line of sight is still this orange guy, but our horizontal line is now this line right here to give us our angle for this angle 4. So our line of sight, the orange line is above our horizontal line. So that's going to be elevation. I'm just going to do a little dot. Okay. Sorry, I'm trying to hold in a cough. Still getting over sickness. It's kind of, DLD day came at a good time. Okay, going ahead and looking at this one, highlight your horizontal line. We got that one right there to make up angle 1. The other half of making up angle 1 is our line of sight. The line of sight is above, so this is going to be elevation. For angle 2, here is our horizontal line for angle 2, because we're looking at this guy. Our line of sight is going down, so this is depression. Okay. Angle 3. Here is our horizontal line for angle 3. We are looking at, I don't know what just happened. Here's our horizontal line for angle 3. Sorry, guys. And then our line of sight's going down. So this is again depression. And then angle 4, our horizontal line is right here. Our line of sight is going up. Here it is. So that is elevation. Okay. Right here is a little word problem practice. When the angle of elevation to the sun is 52 degrees, so angle of elevation to the sun. Here's our horizontal line. Here's our line of sight to the sun. Isn't it pretty? Our line of sight to the sun, that is 52 degrees. If a tree casts a shadow that is 9 meters long, so here's our 9 meters, what is the height of the tree? We're trying to find x. Round to the nearest tenth of a meter. Okay, so we're going to do SOHCAHTOA. Okay, first thing we want to do is, like I said in class, identify, are we solving for a side? Okay, are we solving for a side or angle? Okay, if we are solving for a side, you guys should be using what? All of you hopefully said regular trig functions to yourself. Okay, so that would be regular trig functions. All right, if you are solving for an angle, you use inverse. Okay, so that's step 1. Ask yourself, what are you solving for? Okay, step 2. Okay, label, Ellie, your sides. Okay, so here's our angle in reference. Our x in reference to the 52 should be opposite. Our 9 meters in reference to the 52 should be adjacent. So number 3 is SOHCAHTOA. Identify which one you're going to use and plug it. Okay, in this case, we have an opposite and an adjacent, so we're going to use TOA. Okay, so we will have tangent of our theta equals opposite over adjacent. This is the equation you get from your formula sheet. If you don't know what that guy means right there, plug in what you do know. Okay, so we have tangent of whatever the heck that theta is equals opposite is standing for x over adjacent is standing for 9. Then whatever's left over is our 52 because we only need 3 pieces of information to solve these guys. So we'll plug a 52 in for that theta. Okay, theta always is going to be the degree or the angle, but if you forget that, plug in your knowns, plug in what you do know, and then go back and whatever leftover piece of information you got should be the angle, and you just plug it in. Okay. Now, to solve for this, we want to get our x alone. X is it's x divided by 9. The opposite of divided by is multiply. So we're going to multiply out 9 over 1, the inverse. That over 1 is kind of redundant. You don't need to put it. You can if you want. Those cancel out. On this side, we're going to multiply it out. So we have 9 times tangent of 52 equals x. Okay. Remember to keep your work clean. Okay. I talked to you guys about this in class. Math is only going to get harder, and it is only going to become more and more steps. You need to rewrite it every single time you do something to your equation. That way you're keeping your work organized and clean, and you can actually read what you are doing. All right. I'm going to go to Desmos. Okay, give me Desmos. Okay, we're going to go to Desmos, and we are going to plug in 9 times tangent of 52. Okay, and notice I have a negative. This should be a first clue that if you are getting some negative or crazy number right here, that your calculator is not in the correct formatting. So we're going to click this little graph settings button, and we're going to scroll down. It's in radians mode automatically. Go ahead and click the degrees, and now we have 11.51 or 519. So if it says the nearest tenth of a meter, then our answer should be 11.5 meters. Okay, so we're going to have x equals 11.5 meters. Boom, we are done. Okay. So hopefully that cleared up angles of elevation and depression. Then we have complementary angles. I'm going to do this one really quick too, because we did this in class. Okay. So what are complementary angles? They are two angles that add up to equal 90 degrees. Okay. If we are looking for the sine of A, remember this guy right here. Okay. I know mine looks like a fish. I know we talked about it in class. That guy, or if you want it, it's like that equals alpha. Okay. That guy right there, that's alpha. This guy equals beta. All right. Those are also going to be talking about angles. So they are different. Beta and alpha are different than A, B, and C. Okay. Don't get them mixed up. I know they look alike, but call them alpha, call them beta, call them by their names. I'm so sorry. Okay. If we are looking for a sine of alpha, we are going to look at our SOHCAHTOA. Okay. TOA is going to be kind of redundant, or not redundant, irrelevant in this whole page because it's just not a part of our complementary angles. But sine would be opposite over hypotenuse. So here's our opposite, here's our hypotenuse. So it would be A over C. Sine of beta is talking about this guy, opposite over hypotenuse. So it's B over C. Okay. So cosine. Okay, cosine of alpha is this guy. It's adjacent over hypotenuse, so it's going to be adjacent and hypotenuse, B over C. And then cosine of beta would be talking about this guy. Adjacent's right here at A, and our hypotenuse is at C. So A over C. All right. So what we want to recognize from this is that our sine of beta and our cosine of alpha equal each other, and then our sine alpha and cosine beta equal each other. So we're going to write that sine of alpha equals cosine of beta, and then sine of beta equals cosine of alpha. I know my handwriting is really bad. Move past it. Okay. So those are what we're going to be calling complementary angles. Because the second thing we want to think about is all of your angles inside of a triangle add up to get what? Okay, all of you should have said 180 degrees, right? 180 degrees. If we take away angle C right here, which is 90 degrees, we're left with 90 degrees, right? So by this logic, this answers A2. By this logic, if we want to find this angle and this angle, alpha and beta, because we took away our 90, then we would have alpha plus beta equals 90 degrees. It's whatever's left over, okay? And as we remember, complementary angles are two angles that add up to get 90 degrees. So this is alpha plus beta equals 90. Those are complementary, right? In this case, B, it says what ratios are used to describe BC over AB, all right? We're going to use a little highlighter. BC is right here, okay? Here's BC, and then AB is going to be right here, our hypotenuse. So two functions, we want to look at our angles. If we are looking at alpha, okay, if we're looking at alpha, we're going to have how is our green line related to our alpha, okay? And just pick an angle to start with. It doesn't really matter. Just pick one. Or you could have started with beta. Doesn't matter. Starting with the 90 degrees does absolutely nothing for you. Don't look at that guy. Start with either alpha or beta. So our green line is opposite of our alpha, and our yellow line is the hypotenuse. Okay, we can leave that hypotenuse right there as labeled because our hypotenuse doesn't change. He is always the hypotenuse. So in this case, opposite over hypotenuse, if we look at SOHCAHTOA, remember I told you, literally write SOHCAHTOA all over your paper. It should be scattered. You should be just like, it should be next to like every problem. Okay. Opposite over hypotenuse, that would be sine. So we would have sine of alpha equals BC over AB. Okay. Now, if we look at it in terms of beta, because it says two different ways, so let's look at it in terms of our beta. Our beta now, this BC is an adjacent line to our beta, and our AB is still the hypotenuse. So whatever goes with adjacent and hypotenuse is COA, right? Cosine. So we would have cosine of beta equals BC over AB. All right. Now, if we use trig ratios to describe AC over AB in two different ways, we are now going to look at, let me get another color. AC would be, we're going to use this pink line. AB is still going to be our yellow line. All right, that has not changed. We're going to do the same thing. Pick an angle to start. We already have our beta highlighted, so we can start there. Now, the pink line is opposite of our beta, and our yellow line is still the hypotenuse. So what's working with opposite and hypotenuse? It is sine, right? So we're going to have sine. Here, let me use a regular pen or regular color. Maybe. Okay, we're going to have sine of beta equals opposite of AC over our hypotenuse AB, right? So we've described it one way. Now let's switch and look at a different angle. Let's go ahead and look at alpha. If we look at the alpha, AC is adjacent to our alpha, and our hypotenuse is still hanging out as a hypotenuse, okay? So if we have an adjacent and a hypotenuse, that's working with COA. So we're going to have cosine of alpha equals AC over AB, okay? Now, what can we conclude about sine of alpha and cosine of beta? That's talking about these two guys, right? What can we conclude? Well, they both equal the same thing, so we can say sine of alpha equals cosine of beta, okay, because they both equal the same thing. What can we conclude about cosine of alpha and sine of theta? Okay, now that's talking about these two guys. Okay, they both equal the same thing, AC over AB. So that means sine of beta will equal cosine of alpha. All right, simple as that. Now, this part we didn't do in class, so I want you guys to watch me do part A and then go try the rest on your own. So I'll do part A, you guys pause the video, try the rest on your own. Okay, now sine of our sine of theta equals cosine of 25. Remember, these are two angles that add up to get 90 degrees. So what you do, 90 minus 25 gives you, should be 75. No, 65. I can do math. Okay. 90 minus 80 will give you 10. Okay. Oh, here. Theta equals 65. Okay. Theta equals 10. All right. 90 minus 35 gives you what? That should be 55, right? So theta equals 55. 90 minus 68 gives you 22. So theta equals 22. This one is a little more in depth. All right. We have cosine or sine of theta equals cosine of theta plus 10. Set up your equation. Theta plus plus theta plus 10 equals 90 degrees, right? It's the same thing we were doing here. 60, like if we rewrote all this, that would be 68 plus 22 equals 90, right? So that's what we were doing. Or we were doing 68 plus theta equals 90, and then we solve for our theta by subtracting the 68. So same principle, add them together, they get 90 degrees. So here, if we have a theta plus a theta, this is the same thing as a variable, okay? Combine your like terms. Theta and theta is a like term, so we're going to have 2 theta plus 10 equals 90, right? Subtract out the 10, and we get, I'm going to bring my work over here, 2 theta equals 80 degrees, right? Divide out our 2, and we get theta equals 40. And there's your answer. Okay, go ahead and pause and do part or F. Hold on. Okay. For F, let me get a new color. We have sine of theta minus 20 equals cosine of theta. Okay, set it up the exact same way. Theta minus 20 plus theta, okay, that would technically be in parentheses. You don't have to because it's adding and subtracting. So the parentheses aren't super needed. Equals 90. Okay. So if we ignored the parentheses, because again, they're not super needed. We're not multiplying anything towards the set of parentheses or putting anything to an exponent or dividing. So they're not really needed. Do the same exact thing. Combine our like terms. So we have a theta and a theta. Those are our like terms. So we're going to combine our like terms and get 2 theta minus 20 equals 90. Okay. Add out our 20 because we're still combining like terms. We're going to bring our work over here and have 2 theta equals 110. I don't know why my handwriting is so bad today. Kind of annoying. It just kind of happens. I got good days and bad days. Any of you guys go through that? Okay, divide out our 2 because we're trying to solve for theta, get theta alone. If theta's messing you up, take away the theta, plug in an x. You could just as easily do this as x minus 20 plus x equals 90, okay? You could just as easily solve for that and get 2x minus 20 equals 90. That is okay. If theta is making you so confused and overwhelmed, plug in an x instead of a theta. You're just trying to solve for the variable, so it doesn't really change anything. Okay. Divide out our 2, and you get 110 divided by 2, which would be theta equals 55. Okay. So that would be the same thing over here. You would get x equals 55. All right. Now, our last question for what angle measurement must sine and cosine have the same value? Explain how you know. So if we have sine plus cosine equals 90, in order for them to have the same value, it would have to be 45, okay? Because 45 plus 45 equals 90. You could have figured that out by just going 90 divided by 2 equals 45, right? So they would both have to be 90 degrees. And we know this because sine and cosine are complementary angles. So they add up together to get 90 degrees. So half of 90 is 45, right? Don't overcomplicate it. Cool. We are done with complementary angles. Now is for our today's activity, our DLD day of mixed practice. Sorry, still dying. That has not changed. So now is for our DLD day of mixed practice. This is what your Google Classroom assignment is. And you guys do have this as a packet. So again, if you were not here on Friday and you missed that packet, well, now you are officially caught up with the lesson that we did on Friday. And you are caught up in life. The pages you have access to on Google Classroom, so either just print it out yourself or complete the work on an extra sheet of paper. Don't really care. You guys do you. All right, but you will need your calculators, right? So I may actually do like split screen so I can get, there we go. Yeah. So that way we can have calculator all day. All right. Now, write the expression for cosine of theta for the triangle below. Okay. So again, we're going to have SOHCAHTOA everywhere. I put that. Where are my pen? Does this not give me my pen options? Oh, hold on. I need my colors. How can I teach y'all if I can't color coordinate? Okay. Okay. Huh. That's interesting. Okay. Okay. Here we go. Here we go. Beep. Beep. Okay. Well, I guess that's the best I got. There we go. That'll be okay. That'll work. See? Okay. I got colors. We're good. We're good. No one panic. Okay. Let's hit up our orange. I weirdly like this orange. Okay. We got Toa. Write an expression for cosine of theta. Here is our theta right here. Cosine is adjacent over hypotenuse, so we're going to just label. Okay. T is our adjacent. G is our hypotenuse. So we're going to have cosine of theta equals T over G. That's it. Super. And you're done. Okay. Number 2, as a plane takes off, it ascends and at an angle of 20 degrees elevation. Okay. So in this scenario, our graph is labeled for us. So that's super great. If your graph is not labeled, you have to be able to understand angle of elevation right there. So that would be building your horizontal line. If it's an angle of elevation, then our line would be above our horizontal line, and that would give us 20 degrees, right? So that is what that means. You do have to be able to recognize how to build it yourself in case it is not given to you. If the plane has been traveling at an average rate of 290 feet per second and continues to ascend at the same angle, then how high is the plane after 10 seconds? The plane has traveled 290 feet. Okay, so it's already given and labeled. Here we go, 292. We want to know how high is the plane. So we want to know X, our height. So again, first thing we're going to do, as we talked about, are we solving for a side or an angle? All of you guys should have answered side. If we are solving for a side, are we going to use our regular trig functions or our inverse trig functions? Everybody should have said regular. Okay, so now we are going to label. So we got opposite of our reference angle 20, and this is our hypotenuse. According to our SOHCAHTOA, opposite and hypotenuse is sine. So we're going to have sine of 20 equals opposite x over our hypotenuse, 2900. Okay, multiply your 2900 out because we are trying to get our x alone. So we're going to go times 2900, cancels out. What you do to one side, you have to do to the other side. So times 2900, and we get 2900 times sine of 20 equals x. Okay, this is where we plug it into our calculator, right? 2900 times functions sine of 20. Okay, I'm going to just double check. It is still in degrees. Good. Make sure y'all's calculators are still in degrees. We get 991.86. Does it specify what to round to? No, I do not see it does. Okay, so we're going to do 991. X equals 991.86 feet. Boom, we're done. Okay. Number 2, a person noted that the angle of elevation to the top of the silo was 70 degrees at the distance of 9 feet from the silo. Okay, using the diagram, approximate the height of the silo. Okay, here's our silo. Here's our 9 feet. And there's our angle of elevation. We want X, the height of the silo. Okay. Again, we are solving for side. We are solving for a side. So we are going to use our regular trig functions. Okay. So if we label, here's our opposite. Here's our adjacent. So according to our SOHCAHTOA, opposite and adjacent is tangent. So we are going to have tangent of 70 degrees equals opposite over adjacent, x over 9. Okay, multiply out like normal. Okay, we're going to do times 9, cancel out, times 9. So we get 9 times tangent of 70 equals x. Plug it into our equation. 9 times functions tangent of 70, close our parentheses, equals 24.73. Okay, so x equals 24.73 degrees. And there you go. Now, we have find the measure of the angle theta using inverse trig ratios. Okay, remember, if you are solving for theta, if you are solving for your angle, you are going to use inverse. So if cosine equals 0.823, then we need to find theta. So you are going to go if cosine of theta equals 0.823, then we want to go the inverse, which is multiplying the inverse of cosine on both sides, and that gives us our theta alone. So that cancels and that cancels. Okay, what you did to one side, you had to do the other. So we would have the inverse of cosine over here. So we would get theta equals the inverse of cosine of 0.823. Okay, so if we come into our calculator, we're going to go inverse of cosine, 0.823 close our parentheses, and that should be 34.61. Okay, so theta equals, if we're going to the nearest degree, that's going to be 35 degrees. All right. Number 5, given sine of A equals 5/13, show the diagram to determine the value of tangent of A, right? So if sine of A right here, here's our A, opposite, TOA, okay? We haven't rewritten it in a minute, so we'll do that. If sine of alpha A equals 5/3, then this, or 5/13, I don't know why I keep saying 3. 5/13 equals opposite over hypotenuse. So 5 is going to be our opposite, or BC will be our opposite 5, and our hypotenuse, here's our hypotenuse of 13. Okay, so if we are looking for tangent of A, okay, tangent is opposite over adjacent. So we need this guy first, all right? So if we need AC in order to figure this out, anybody have any ideas of how we can find AC? Anybody? Pythagorean theorem, that's right. A squared plus B squared equals C squared, okay? So this would be A squared we can call it X squared, plus B squared would be 5 squared equals 13 squared. Okay, so X squared plus 25 equals, I think that's what, 169? 13 times 13, yeah, 169. Okay, subtract out your 25. Minus 25, that gives us x squared equals 9 minus 5 is 4, 6 minus 2 is 4, 1. Okay, take the square root of both sides. X equals square root of 144 is 12. Woo! Okay, so x right here, AC, now equals 12. We know this. So our tangent of A would be opposite over adjacent. So 5 is our opposite, 12 is our adjacent. So tangent of A equals 5/12. Boom! Aren't we smart? Okay, go ahead and try and B and C by yourselves. Okay, so if we have cosine of 6/10, okay, cosine is adjacent over hypotenuse, cosine of M. That's talking about this one. Adjacent would be 6. Hypotenuse is 10 right there. And the diagram shown on the right. Find the sine of M. So again, you guys have to do the same thing. You need the sine of M, which sine is opposite over hypotenuse. So we need to solve for our opposite, x. So you're going to do the same thing. Throw it into the Pythagorean theorem. 6 squared plus x squared equals 10 squared, okay? 36 plus x squared equals 100. I'm sorry. Subtract out our 36. 100 minus 36 is 64, so x squared equals 64. Take the square root of both sides, and we get x equals 8. Okay, it is nice that this is turning out so clean. X equals 8. Okay, so the sine of M, we're still working on this, would be opposite over hypotenuse. So it would be sine of M equals opposite 8 over hypotenuse 10. Okay. I'm so sorry, guys. All right, now we got tangent of A. So here's our A. Tangent is opposite over adjacent. So 3/4 would be opposite over adjacent. So here's our A, 3/4. Now we need to find the cosine of B, okay? So we're looking for our cosine of B right here. And cosine is adjacent over hypotenuse. So here's our adjacent, 3, but we need our hypotenuse, right? So we're going to go 3 squared plus 4 squared equals h squared. We're keeping h as hypotenuse. So 3 squared is 9 plus 16 equals h squared. 9 plus 16 gives us 25 equals h squared. Square root both sides. h equals 5, right? So h equals 5. So cosine of B, I almost called it beta, of B equals adjacent of 3 over a hypotenuse of 5, right? I know, this is a lot of work, but you guys do this and you guys do it yourself and then use my video to check your work, and you guys should crush this test when you come back on Thursday. And I will be so stinking proud. And all y'all will be so stinking happy. All right. In right triangle SRT shown in the diagram, angle T is the right angle. Okay. So here's our angle T is our right angle. It's already labeled for us. Angle angle R is 34 degrees. Determine the approximate value of A over B. Leave your answer as a decimal to the fourth places. Okay. All right. Give me a second because I need to go get more water. All right, guys. Sorry. Had to get more water. So, you would think it would fix my cough, but no. Okay. So we were determining the approximate value of A over B in reference to our 34 degrees. So what we want to do when we first look at this is look at what is our A in reference to the 34. Okay. It is the opposite. Our B in reference to the 34 is adjacent. So if we look at our SOHCAHTOA, all right, we look at our SOHCAHTOA, that's TOA opposite over adjacent. So we would actually have tangent of 34 equals O over A, right? So all you do, and get rid of all this, is functions tangent of 34, and it, sorry, so it's to the fourth decimal place. So we would do O over A equals 0.674, and then it goes 67450. So that's just 5. We don't have to round this. So boom, there we go. And then for number 7 in the right triangle, FGH shown on the diagram, angle H is the right angle. Angle F is 58 degrees. Approximate the value of A over C. So again, we're going to look at how our A and our C are in reference to our degree. So here's our degree. A right here is an adjacent. C is our hypotenuse. So adjacent and hypotenuse is cosine. So cosine of 58 would equal adjacent over hypotenuse, which is A over C. Okay, so plug that in. We do functions cosine 58, close our parentheses. That would give us to the fourth decimal places, A over C equals 0.529, and then our 9, 1. So that's going to just stay a 9. And then there we go. Okay. Now it wants us to find our unknown angle in the diagram. All right. We got 2 triangles here. We know our rules. Okay. We can recall from last semester and solve this thing. Don't be overwhelmed. All right. First thing, we want to figure out what we got. Here's our angle in reference. We have one side. We need 2 pieces aside. Okay. We have no idea what AD is. If we look at DB, this entire length, we got half of it. We got 3 centimeters. We need this other half in order to get this whole length to solve for our angle. Okay, so until we get that length, we're just going to hold off on our green triangle. Ignore him. Completely ignore him for now. He's not relevant. Come to our blue triangle. We have our 5 centimeters. We need to figure out what this guy is in order to get the whole length. Okay, so we need to figure out this little length right here to start with. And we are given 5, so we're given our hypotenuse, and we need this one. Now, here's 90 degrees. We don't know what this angle is, but we can figure out that guy, right? Because what we are given is a straight line. And we all know that straight lines add up to equal 180 degrees. So what we're going to do is we're going to go 180 minus 144, and that gives us 36. So we now know that this angle right here is 36 degrees, okay? Use your rules, figure it out. I believe in you, okay? Now, in 36, this x in reference is an opposite. And then again, we got our hypotenuse. So again, if we look at our SOHCAHTOA, opposite and hypotenuse is sine. So we can do sine of 36 equals our opposite x over our hypotenuse 5. All right. Multiply the 5 out to get x alone. So x equals 5 times sine of 36. Okay. We're going to go plug it in. 5 times function sine of 36, close our parentheses, gives us 2.94. So x equals 2.94. All right. Now, we know x equals 2.94. We also know that BC equals 3. So we could do 2.94 plus 3 equals our entire length of this guy, our entire length. So that would be 2.94 plus 3 gives us 5.94. Okay, so that gives us BD, right? Now I'm going to get rid of this cluster. This entire length right here is 5.94. We want to solve for theta. So in reference to that, 5.94 is our opposite. 8 centimeters right here. This guy is our hypotenuse. So that is going to be opposite over hypotenuse, right? Where's my SOHCAHTOA? Right here. Opposite over hypotenuse, sine. So we're going to have sine of theta equals opposite 5.94 over 8 centimeters of our hypotenuse. Now, if you guys remember, when we are solving for theta, we have to use our inverse trig function. So we're going to multiply both sides by our inverse trig to get our theta alone. So we have theta equals our inverse of sine times 5.94 over 8. Okay, and you could have set it up exactly like this if you remembered how to do that. If you didn't, that's okay. Just multiply both sides. So we're going to have functions, our inverse sine equals 5.94 divided by 8, and then get out of your fraction and close your parentheses. Okay. Theta will equal, if we just round up to the nearest degree, 48 degrees. So that guy is 48 degrees. Woo! All right. Last problem for this page is number 9. I know this is a really long video. I'm sorry, guys, but the more practice, the more you're going to crush your test. Okay. Find our unknown x. Okay. So we are given 2 triangles. X right here is this guy. We are given 8 centimeters, but we have no idea what these angles are. In our purple triangle, we are given 2 angles, and we don't know what that guy is. We know all angles inside of a triangle add up to get 180 degrees. So we're going to go 180, go back. 180 minus 31 minus 115. And that gives us 34 degrees. Now, you guys should be able to recognize, because we know these things, that this angle and this angle are vertical angles. So that means this guy is 34 degrees. Okay. Now, if we know one of our degrees in our red triangle, we can solve for x. So in reference to our 34 degree right here, we have an 8 centimeter, which is an adjacent, and we have x, which is our hypotenuse. So if we look at our SOHCAHTOA, okay, that would be adjacent and hypotenuse, so that would be COA, right? So we got cosine of 34 equals adjacent of 8 over x of our centimeters. Okay, I'm going to get rid of that guy. Sorry about this. Now, long story short, these 2 guys can just switch. So these guys just switch. If you don't understand that, we'll solve like normal. Multiply your x because it's in the denominator. We can't do anything with x in the denominator. We got to get them out. So we got x times, I am recording, right? I was recording. Yeah, I'm recording. Oh, that made me nervous. Cosine of 34 equals 8. And then we can divide by the cosine of 34. No, we are not using the inverse because there's no need to separate our cosine from our 34. That's just one whole number, one whole unit. Keep them together. 34, and we get x equals 8 over cosine of 34. So if you don't remember what steps, solve for x like normal. Do your normal thing, okay? And we get 8 divided by cosine of 34, close our parentheses, and we get 9.65. There we go. So that's what x equals. All right, we are done with this. Woo, mixed practice complete. Okay, let me see if, go away. Okay, our last worksheet is the solving right triangles. Okay, we're so close. This one is a bit long. That's okay. We got this. Okay, pause the video if you need to go take a bathroom and snack break. But let's do this thing. Okay. Problem solving. In each diagram, solve for the side CD. Okay. So let's go ahead and write. So, toa. Okay. Again, where did my, oh man, lost it. Okay. Okay. Hold on. I gotta get my little colored pins back. There we go. There we go. I don't know why it's so finicky. Okay. Toa. So let's, first thing you want to do is find your CD. Here's our CD right there. Okay. 32 is our reference angle. So we would have, this is adjacent. Okay. And this is our hypotenuse. Adjacent hypotenuse would be cosine of 32 equals adjacent x over 75. Multiply out your 75, multiply out your 75, and you get, rewrite it, 75 times cosine of 32 equals x. So we would get x equals 75 times functions cosine of 32. X equals 63.6. Okay, or CD equals 63.6. Okay. For B, here is our CD right here. This guy. Okay, so if our reference angle is 56, this is opposite, CD is our hypotenuse, that gives us sine, so sine of 56 equals 28 over h. Remember what I said, these guys just flip, okay? If you don't understand that, go scroll back, watch that last problem I did on the mixed practice worksheet, and you would see that h equals 28 over sine of 56 if we solve like normal. But I'm not doing that every time. 28 divided by functions sine of 56. Again, you guys should be working on this worksheet by yourselves. This video is to check your work or if you get stuck. Okay, so CD, or H as we want to call it, equals 33.8. Okay. In this case, CD is right here. Okay, so he is an adjacent, while our 15 is an opposite. That would be TOA, right? Tangent of 43 equals opposite 15 over our adjacent CD. Again, these guys flip-flop. So we get CD equals 15 divided by tangent of 43. So CD will equal 15 divided by functions tangent of 43, 214.5. Okay, here's our CD. Here's our reference angle, 27. CD is an opposite. Our other given side is a hypotenuse. So that would be sine of 27 equals CD over our hypotenuse, 35. Multiply the 35 out. And we get 35 times sine 27 equals CD. Okay, so 35 times functions sine of 27. No, go back. Where's my little back button? 27. I can go away. And that gives us 15.89. So CD equals 15.89. Okay. Right now I keep flipping back and forth what I'm rounding to. I normally like 2 decimal places out like this unless it specifies. Always look and see if it specifies. Like for number 2, it says to the nearest 10th. Okay, in the diagram below, which of the following represents MN? So here's our MN. Okay, so that would be adjacent to our 40 degrees, while this is opposite. All right, so that's adjacent, opposite. That would be, for our SOHCAHTOA, tangent. So tangent of 40 equals opposite of 24 over adjacent MN. Okay, those guys would flip, so we'd have MN equals 24 over tangent of 40. So 24, whoa, that was a fun trick. 24 divided by functions tangent of 40. Okay, and that gives you 28 point, it says to the nearest 10th, so 6. So that would be our answer. All right. Number 3, in triangle QRS, R is a right angle. Okay, R is a right angle. Angle Q equals 57 and QS equals 35. So draw your triangle. Here's our right angle. So this would be Q. R is right angle. So R is here. S, right? That's a right angle. Q is 57 degrees. QS is 35. Which of the following expressions correctly calculates QR? So we're looking for X right here. All right. So X would be an adjacent to our 57. 35 is the hypotenuse. So adjacent and hypotenuse of SOHCAHTOA would be cosine. So it would be cosine of 57 equals adjacent over hypotenuse. So X over 35. If we went and we multiplied this to solve, we would have times 35 on both sides. So we would have X equals 35 times cosine of 57. So 35 times cosine of 57 would be that answer right there. All right. Oh. In a rectangle ABCD shown below, CD equals 24. Angle A, B, oh, this is a B, guys. D equals 35. Determine the length of diagonal BD. So we want to know this guy right here. To the nearest 10th. Show your work. Okay, so in a rectangle, you guys got to remember what your rules of the rectangles are, all right? Our rules of a rectangle means this guy and this guy are congruent, and they are also parallel. It also means this guy and this guy are congruent, and they are also parallel, right? These are our rules of rectangles. Rectangles also have 4 right angles. So this would be a right angle, that would be a right angle, that would be a right angle, and that would be a right angle, right? Okay, so we are working with this. We know this guy equals 35, right? If we have 2 parallel lines, here's a parallel line, here's a parallel line, with a transversal line going through them, then this angle and this angle are what? All of you guys should have said alternate interior angles. So this also equals 35 degrees. If you wanted to go another route and you know that this is congruent to this side, you would have also recognized that that's 24, okay? So I'm going to get rid of all this cluster. 24, and that's 35 degrees. Okay, if we are trying to solve for the hypotenuse, we only need to focus on one of these triangles. So we have our 35 degrees right here. I don't know why that erased. 24 in reference to this angle is adjacent. Our x is a hypotenuse, right? So we're going to have an adjacent and a hypotenuse. That would be cosine. So cosine of 35 equals our adjacent 24 over our hypotenuse BD. Okay. And so that's our x. BD is our hypotenuse, this guy. All right. Like I said previously, these guys just switch. If you don't recognize that, do the math, multiply out BD. But we get BD equals 24 over cosine of 35. So let's plug it in. 24 divided by functions cosine of 35, and that should be 29.3 or 29. No, it'd be 0.3. 29 point. If you did two decimals, it would be 0.30 because the 9 would round up because of that 8, so then it would be 0.30. Okay. Boom. There we go. And it says to the nearest tenth. So we actually don't need that because to the nearest tenth, so it'd be 29.3. All right. Boom. So if we have an isosceles triangle with the legs the length of 12 and the base is the measure of 28, what is the measure of its base to the nearest tenth? Be careful with this one, okay? If we have an isosceles triangle, we know that this guy is congruent to that guy, okay? So his legs are 12 and this is 12. And then it says a base angle that measures 28. That would be in reference to this guy, 28, okay? So what is the measure of its base to the nearest tenth? We can't, this isn't forming a right triangle, so like that makes our job hard. What we can do is split him right down the middle, right? Split him right down the middle. That gives us a right angle here and a right angle there. So we can solve for this half of a length and call it x. Whatever we get for that, that would be congruent to this side as well. So let's go ahead and do that. So here's our triangle. This 12 would then become the hypotenuse if we have this middle triangle like this. And x is adjacent. So adjacent over hypotenuse would be cosine of 28 equals, right, adjacent over hypotenuse, x over 12. So multiply by our 12. Cancel, let's multiply by 12. We get 12 times cosine of 28 equals x. So 12, go back, times cosine of 28. And that gets 10.59, all right? Now, again, it is only this side right here, so we need that times 2. So this would be 10.595 equals x. If we multiply him by 2, that will get us this entire length, okay? So 10.595 times 2, and that gives us our entire length, so the base to the nearest tenth equals 21.2. Okay. Number 6, a ladder leans against a building that is perpendicular to the ground that makes a 74-degree angle with the ground, and the bottom line is 2.75 feet from the base of the bottom building. Determine the height of the ladder that reaches up the wall to the nearest foot. So the height right here is this guy. And then how long is the ladder to reach the nearest foot? This would be the length of the ladder for B. Okay, so the first thing we want to do, this is opposite. This is adjacent of our reference angle. Opposite and adjacent is tangent. So tangent of 74 equals opposite. So our height over 2.75. Okay, multiply that out. Times 2.75 times 2.75, and we get 2.75 times tangent of 74. Okay, so our height of the ladder to the nearest tenth of a foot would be 9.6 feet. Okay, 9.6 feet. Now, you could use Pythagorean theorem to find the length of the ladder, or you could do SOHCAHTOA. Okay, if that's the case, this is our hypotenuse, and this is still adjacent. So adjacent and hypotenuse works with cosine. So we would have cosine of 74 equals adjacent 2.75 over our hypotenuse, x. Those guys will switch. So we get h equals 2.75 over cosine of 74. So we go ahead and plug that in. Okay, to the nearest ground to the nearest foot. This would be 10 feet. So our ladder is 10 feet long. Okay. Go ahead and pause and try number 7 by yourself. Okay, a ladder will be unstable if the angle makes. Am I recording? Yeah. If the angle it makes to the ground is greater than 60 degrees. If a 12-foot ladder is used to reach a 10-foot window, or a window 10 feet above the ground, will it be unstable? Justify your answer. Okay. So in this question, we are talking about this angle right here. Okay. What this means right here is that if that angle is greater than 60 degrees, it's super unsafe and you need to adjust your ladder. Okay. So anytime in the world you guys are doing things, especially with ladders and roofs, things like that, you want to make sure you are following all the safe protocols. Now, in this example, 60 degrees is probably a made up angle. I don't know, Google what the correct angle would be for like safety with ladder usage. But you want to make sure you're using a correct angle so you're not like too straight up and down, because if you're like this, that's super probably unsafe. You're going vertical. And if you are too far out like that, also probably unsafe. So I wouldn't recommend it. So there is like set angles that people will use, and most people just get in the habit of like kind of knowing where it's at. Okay, I'm done rambling. We want to figure out what this x is to know if it's safe or not. That's all our question is asking us. Find that angle. Okay, so in reference to this angle, our 10 feet is opposite, our 12 is hypotenuse. So Toa. All right, that would be sine. So sine of x equals opposite of 10 over our hypotenuse of 12. Again, if we are solving for angles, okay, this is an angle. We could have also plugged it in and we could have said this is theta. If we are solving for theta or our angle, we are going to use the inverse function. Oh, we are going to multiply both sides by inverse of sine. Okay, that cancel out over here. Multiply this side by inverse of sine. So we get theta equals the inverse of sine times 10 over 12. Okay, so that gives us functions inverse of sine, 10 divided by 12. Okay, close our parentheses, and we get our degree is theta is 56.44 degrees. Okay, so if it's greater than 60, it's unsafe. So right here we are safe because it is less than 60. All right. To determine the height of a tree, loggers will measure the angle of elevation from the top of the tree to the top of the tree from a, I don't know what happened, it got cut off, distance from the base. If the logger's eyes are 5 foot 3 inches, hey, that's my height, above the ground of the angle of the elevation, the tree is 38 degrees. Okay, angle of elevation. This is where we're talking about this again. So we got our logger right here. Here's our logger. He sees the top of the tree. It's 38 degrees. And then he is standing 25 feet from the base of the tree. So right here, this is 25. What determine the height of the tree to the nearest inch? So we want the complete height of the tree. right? Now, if you notice, our triangle only gives us this amount right here. Here's our triangle. So we're going to have to find this height right here and then add the height of our little logger, 5'3". So let's set it up. To find the height first, this would be opposite, and then this is adjacent of our 38 degrees. So opposite and adjacent would be TOA, right? So that would be tangent of 38 equals opposite. We're just going to say, we're going to leave it opposite. Over, no, we're not going to leave that because you guys may think that's a 0. We'll call it X. Over 25. Solve for X, so multiply out our 25. Okay, and we get 25 times tangent, 38 equals X. So 25, go away, 25 times tangent of 38, close our parentheses, equals 19.53. Okay, so now we have to add, we need to add 5'3". So what this means right here, what this number is this is 19 and a half. Okay, 0.5 is a half. So what this translates to is 19 feet. And what is half of a foot? Half of a foot is 6 inches. Okay, that's where it's like, hey, remember 12 inches in 1 foot. So half of 12 is 6. So that's just 19 and a half, but it translates to 19 feet, 6 inches. So we're going to add our 5'3" little logger. So that's going to be plus 5 foot and 3 inches. And that gives us 9 inches. 19 plus 5 is 24 feet. So our tree is 24 feet and 9 inches. Boom. Okay. In a trapezoid, ABCD, AB is parallel to DC, and BC has a right angle to DC, so that's already labeled. And the sides and lengths as shown. So AB is 5 inches, DC is 7 inches, BC, sorry, is 3 inches. Determine the measure of D to the nearest degree. Okay, so trapezoids. We know this is a right angle, that's right angle, that's it. So if we go ahead and like just split this guy and make ourselves a triangle right here, okay, we have now created a rectangle where this would also equal 3 inches because this would be congruent to that guy, okay? So we know that's 3 inches, and we know this would be congruent to this. So this would technically be 5, and this guy would be 2 inches right there, right? Because that's the leftover. That's what the difference between, that's what the difference between this side and that side is. 7 minus 5 gives us that leftover 2. So if we're trying to find this degree right here, we know this guy's 2 and this guy's 3, so that would be adjacent, and then this is our opposite. So that would be SOHCAHTOA, opposite over adjacent. So we would have tangent of theta equals opposite of 3 over adjacent of 2. Okay, multiply both by the inverse because when we're solving for theta, we need to use our inverse. So we would have theta equals the inverse of tangent of 3 over 2. What are my dogs doing? They're being such good boys and girls. If I recorded this video like 2 hours ago, all you would hear is barking. Okay, inverse of tangent, 3 divided by 2. Okay, and this says to the nearest degree, so that would be 56 degrees. So D equals 56 degrees. Now it wants us to find the length of AD. So the length of AD would be this side right here, right? in the simplest radical form. Okay, now we could use our 56 degrees, or we could just use our Pythagorean theorem. So a squared plus b squared equals c squared. In this case, 2 is a squared. 3 could be b squared. If you switch those, it does not matter. So actually, that would just be b, and that would be a. So 2 squared plus 3 squared equals c squared. Okay, 2 squared is 4, plus 3 squared is 9, equals c squared. 4 plus 9 is 13, equals c squared. Take our square root of both sides, and we get c equals the square root of 13. Okay, it says simplest radical form, so we are not going to find the decimal of the square root of 13. We are going to leave it as the square root of 13. That's the simplest radical form. Okay, all right, this should be our last question. Look at us go. All right, a tower is located 327 feet from a building in the figure below. A person in the second story measures the angle of elevation to the top. Okay, so here's our horizontal line in our second story. Here's our second story. So our guy right here is me. There's our dude. His elevation, angle of elevation, so the vertical, the line of sight above our horizontal line, and that gives us 32 degrees. And the angle of depression, so here's our horizontal line. Our angle of depression would be a line below the line of sight below our horizontal line, which is right there, 18 degrees, to the bottom of the tower. Find the height of the tower to the nearest tenth of a foot. So we want to know what this height of the tower is, h. Now, we are given these two triangles, right? They made it simple for us. All we got to do is find the height right here, and then the height right here, and add them together, okay? It gave us all the other information. If our building in the tower is 327 feet, then this is also 327 feet, okay? So opposite, let's work on our top triangle first. This would be an opposite. This would be an opposite. And this right here is our adjacent, okay? So if we're looking at our SOHCAHTOA, opposite and adjacent is tangent. So we would have tangent of 32 equals opposite. We're going to call them x over our adjacent of 327. Multiply this 327 on both sides to cancel him out. Okay, so we would have 327 times functions tangent of 32. Okay, and so this gives us x equals 204. Now this is to the nearest tenth of a foot, so we're just going to round to the tenth of a foot, so 0.3, okay, feet. Now, we need to do the same thing of our bottom triangle with the angle of depression. So we have this 18 degrees. We still have the 327. That's adjacent. And then this guy right here for our height is going to be, again, opposite. So we're going to have tangent of 18 equals our opposite of x over 327. The exact same problem, just you are plugging in 18 for your degree instead of 32. So multiply 327 out, multiply 327 out. So we get 327 times functions tangent of 18, close our parentheses, and we get x equals 106 point, round to the nearest tenth would be, stay at 2. Now, what we do to finish this problem off is we add them together. So this guy plus this guy would give us our full height. So 204.3 plus 106.2 equals tower height. And so on. Okay, so 106.2, which normally I like to round at the very end, but whatever. 204.3. If your answers on like the test aren't matching up, I would go in back and plug in this full number and plug in that full number, add them together, and then round. It may just change your decimal by a smidge. Okay, so our tower height equals 310.5 feet. All right, I think we are done. Good work, team. Super proud. Look at us go. So I will go back and I will fix that Google Classroom stuff. But this is all the homework. I just did it right there with you guys. I know it's super long. But again, this is to help you guys on your test on Thursday. Okay. I will keep all updates right here on our Google Calendar page. So if anything happens crazy tomorrow and I don't see you guys again tomorrow, there will be more updates here. And there will also be updates in our Google Classroom page. So be sure to check both. I'll put the video, well, that doesn't matter because you guys already see where this video is. Okay. Enjoy your day. Have fun in the snow if it actually snows at your house. Goodbye.